So, my name's Christian Riley. As a short intro, I don't really like intros very much. I work for Raiffeisen Informatik, which is a really small company in Austria. Not many people have heard of them. But we actually have a cert team, and I'm a member of the cert team. And I've also previously done penetration testing and various different things, previously talked at a few conferences. So I'm a firm believer in the wisest man is he who knows that he knows nothing. And I can quite safely say I know absolutely nothing. So this is going to work really, really well. I really kind of like edge cases. It's kind of my thing, is like things that are kind of freaky, interesting, off-the-wall things that people don't think about. I really kind of like that kind of stuff. And I kind of like going back in history a little bit and picking out issues that people have found before with different technologies and then trying to apply them to new technologies. And this is what really drove me to do the research that I'm going to talk to you about today. So we're going to talk a little bit about the why I did this, the scenario that I was following to try and prove something, how we go about it. We're going to take a closer look at how we can implement these kind of issues, and then we're going to make it easy, because everyone likes to make things really easy by scripting things up. And then we're going to do a final review, go through and see what we've really learned. So, why are we here? We're here because, well, basically because BYOD. Okay, it's the new buzzword over the last couple of years. Everyone wants their own iPhone, everyone wants their own Android device. No one wants the clunky old BlackBerry, so everyone wants the new technology. And that brings with it a whole load of new problems. Okay, there's just far too much information. And everyone wants that information to their fingertips. You don't want to go looking for it. You want that information right there in front of you. And you want to be able to access it from wherever you are. So you've got all these little containers that contain your files, contain your emails. They contain every portion of your life, but you want them in the cloud. And there's a variety of different applications that allow you to just throw data into the cloud and then access it from wherever you happen to be. So you've got things like good technology, LastPass, which we're going to be talking a little bit more in detail about today. You've got other things like Box and Dropbox, Evernote, SpiderOak, thousands of different applications that allow you to put your information up in the cloud and access it wherever you are. So you've got these multiple use systems where you've got password databases, you want your corporate email in some kind of secure container on your own personal device or on some snazzy device that you've got assigned to you by the company, and you've got secure notes and files. There's so many different ways and uses for putting data up into the cloud and then accessing it from your mobile device. So you've got all this data up in the cloud. How are you going to get it out? And more importantly, how are you going to get it out securely? So you need some kind of application that's going to interface with these cloud services. But the problem is that the device is insecure. Okay, so the device is inherently insecure. I mean, how many updates were there for iOS? Just after they released 7, there were 3 separate updates to fix pin bypass issues. Okay, so the devices are simply not secure. They're not suitable for the purpose. You know, or worse, you've got bring your own device. You don't even have control over the device. You can say, sure, bring your own phone and we'll try and enforce some kind of rule set. But chances are you don't really have ultimate control. It's just a freaking nightmare. You don't have control over the device. The device isn't secure, but you want to keep your corporate information secure. How are you going to go about doing it? So what's the solution? Well, you move security closer to the data. You know, it's not rocket surgery. It's not brain science. You simply say, we need to move this closer to where the data is. So you get another problem. I lost my phone. Okay, well, you know, that happens pretty regularly. I got some statistics from London because they're nice enough to share how many people get robbed in London. 10,000 devices were lost in 2011 in London. So 10,000 devices in a city of 6 to 7 million people. 314 phones a day. And that's only the ones that are reported. So it's probably at least twice that. And now you've got more mobile devices. Everyone's carrying at least 2 now. So it's going to become more and more prevalent that devices are lost or devices are stolen. So what's the state of device security? We've already talked a little bit about how easy it is to bypass the pin. You know, on Android, it's even worse. you just hold it in a certain way, you can see where the pattern is. You know, so there's pin bypasses. You get them on Android, you get them on iPhone. The only thing you don't get them on is BlackBerry, but no one wants to use a BlackBerry anymore. It's the secure option, therefore no one wants to use it. So keep calm. How are we going to solve this problem? It's obvious. Secure containers will save us. You know, or not, as we'll see. So what's the scenario here? Okay, the scenario that I was looking at was physical access to a device. What kind of protection do these secure containers provide? Okay, the marketing is amazing secure container. If you use us, everything's secure. Even if you lose your device, there is auto wipe, there is pin protection. Everything is absolutely fine, even if you lose it or your phone is stolen. So what can we do with temporary access? 2 or 3 minutes. Realistically, probably less than 60 seconds, you can do these kind of attacks. Or what can you do with permanent access to a phone? If you actually find a phone lying on the floor and just, okay, I'll just see what I can do with that. Not that anyone would, but these things happen. And physical access has always been game over. You know, it's one of those things that we've learned for the last 20 years. As soon as you have physical access, that's it, it's over. But, there's that word again, but. Remember that secure containers will save us. This is their purpose. There is no requirement for a secure container other than protecting it when it's on the device itself. Protecting people who have physical access, who are sitting in front of the device, from actually getting access to any of the data. This is their purpose in life. So they should be able to do it relatively well. So what are the goals? The TLDR is PWN secure containers. It's pretty obvious. Not my goal, because you have to kind of restrict these goals. I don't want to bypass the pin. Everyone's talking about how you bypass the pin. There's thousands of people talking about it. There's lots of YouTube videos that are really badly done on how you flip the iPad and then do a special call and then you bypass the pin. I don't want to talk about that because you could waste half of your talk just talking about how you bypass the pin. Let's just accept that they exist and they will continue to exist because mobile providers don't know how to code. I also don't want to root the device. It's too easy. It's an easy win. Plus, on some devices, you're going to lose the data when you root. So I don't really want to root the device. I also am kind of lazy. I don't want to do anything that resembles getting my hands dirty in any way. So I don't want to spend hours and hours in IDA Pro digging through code. I'd rather take the easy money route. Okay, so what can we do pretty easily and pretty quickly with mobile devices? So how are we going to do this? Let's keep it simple. It's always best to keep things simple. So ADB, Android Debug Bridge, is an interface for interacting with Android devices. Okay, so it's pretty standard. Most people who've done anything with Android have used it for a multitude of things. It's really easy to use. It requires something called USB debugging to be enabled, okay, which is one of the crux of the issue here, is that you need some way of enabling USB debugging, which is the reason why we're not going to talk about bypassing pins, because it's so easy to bypass the pin. You can just go into the settings and enable USB debugging if you find a device. That's if they actually enforce pins on the devices through your bring your own device anyway. ADB also doesn't require you to be root on the device, which is good because we don't want to be root on the device. If it's already rooted, that's going to make things really, really easy, and it's going to make these attacks just trivial to do, but we're going on the basis that it's not a rooted device at all. So for those people who don't know, what are the ADB functions? So you can use Android Debug Bridge to sideload applications and uninstall applications, even if a device is pin locked. So it's one of the things you can use to maybe bypass pins. You can install applications in the background without actually knowing what the pin on the device is. You can also sometimes uninstall protections. There's a few applications in the Google Play Store that specifically prevent you from doing things like app lock. You just enable ADB debugging, and then you uninstall app lock, and then you can do whatever you want. It's a simple bypass. ADB, since version 4 in ICS, also supports ADB backup, which is great. It's a really nice feature. You can back up the entire device. You can back up individual containers, individual applications. You can back up the APK files, which are the actual applications themselves. Okay, it's easy. It's a nice little command. You just run ADB backup. You specify which application you want to back up, com.android.app, where you want the AB file to be. Finished. Nice and simple. Obviously, the flip side of it, you can restore it back, because if you can't restore it back, it's pretty useless to back it up. So, very simple, but you need to be able to actually accept that on the device. So if the device is pin locked, you can't do that. You can also use ADB push-pull, uploading, downloading files to the device itself, again, while it's pin protected. So you can start searching through their files and just download stuff even though it's pin protected. You can also do an ADB shell. You're only going to get a restricted shell, but even with a restricted shell, there's a significant amount of information stored on the SD card that you're going to be able to search through and have a look at. So as it works with pin protection enabled, that's also an interesting way of getting access to the devices. So aside from ADB, we're going to need a couple of other supporting tools. We're going to use OpenSSL, which is pretty much on every single Linux box. Unfortunately, it needs to be done with zlib support. So half the time you end up having to recompile it with the right support. But OpenSSL with zlib support, and a tool called Star, which is a version of a tar tool that has a couple of added functionality pieces that we need. It creates, or can be used to create, a list of files in a tar file, and then specify what order they're in, which is something we're going to need for a couple of attacks later on. So let's take a closer look, okay? So we've talked a little about the basics, what we want to achieve, what the functionality is that we're going to be using, ADB and Android Debug Bridge. We're going to talk a little bit about LastPass, okay? So I don't want to specifically ask who uses LastPass, because that would be kind of like calling people out. But, I mean, who uses some kind of password database in their work? Okay, so some people, depending on how tired you are, because it's the last day of the conference. So most people nowadays are being pushed in that direction of using some kind of password database, okay? LastPass is one of the easier options. It offers an online service. Also offers an enterprise option, which is kind of interesting for companies smaller companies, who might need some kind of assistance with a password database. Okay, so it uses an online sync. Again, it's in the cloud, but you have an application on your phone, and it can be secured with a PIN. Okay, that's security. It can also wipe data after 5 false logons. Okay, so we can't even brute force that unless you're going to guess what the PIN is within the first 5. Okay, so chances are pretty slim unless you know what the password is. You're never going to be able to get in. Also restricts screenshots, except that one, obviously, but that's one of those things. So yeah, even the restricting screenshots doesn't really seem to work, depending on how you do the screenshot. But LastPass also has this option to store your password, which would seem pointless. Why would you store your LastPass password in the LastPass database? It's like, I don't want to store it in the application. It needs to be secure. The problem is that why would you store it? Well, if this is the last password I ever have to remember, it's not going to be password 1234. It's going to be something huge and long and complex. And have you ever tried typing that in on an Android phone? Trust me, it's not fun. So chances are you're going to get it to remember your password, and then you're going to say, oh, just protect it with a PIN, because it will auto-wipe itself after 4 or 5 attempts. So you're feeling that level of security because you're PIN protected, okay? So it's okay. You can enable a PIN. So we're secure, okay? So you can set a 4-digit PIN. You can't set anything longer. You can't set a password. All you can do is set a 4-digit PIN, and it will automatically wipe after 5 logons. PINs are secure. Simple as that. It's the way things are. Well, maybe. It could be the way things are, but it's kind of not. So we're going to look a little bit about the Android manifest file of LastPass. If you've ever looked at an Android manifest file, you don't need to read the details because they're not really that interesting, but you have a number of different settings, and it basically says what this application does, what the intents are, so how it starts itself. And it has a number of settings in there that you can configure. Okay, and one of the settings is Android allow backup. Okay, now I've put true in yellow here because the default is true. So if you're a developer of an Android app and you have no idea what allow backup is, then you've turned it on. Simple as that. And when speaking to a few Android developers, they had no idea what allow backup was. So they're all defaulted to true. And in pretty much every application I've seen and every app I've tested in the direction of this research, it's always been completely omitted from the Android manifest. Okay, so we can do this. We touched on it earlier on. We can do a backup, and we can say, I want to back up com.lastpass.lp Android to this file, lp.ab. Simple as that. Okay, so now I've got this AB file. Okay, what good's an AB file? Well, it's basically a zlib compressed file. So you can run through OpenSSL with zlib compression. You just do a DD, skip out the header, put it through OpenSSL zlibs, and what you get out the other end is a tar file. Okay, so basically you look at the tar file, you look at the structure, and it's like, oh, well, that's kind of nice. There's some XML, and that one looks interesting. LP Android.xml. So in the XML file, not always in clear text, but in the XML file, there's the encoded LastPass username, or the LastPass username in clear. There's basically your email address. There's your encoded password, and there's an encoded PIN. And there's a variety of other settings depending on how you've configured your LastPass box. And there's this string, which kind of caught my attention the first time I was looking at it. As I was starting to think, oh, how am I going to brute force this password? Is it encrypted? Is it hashed? And I thought, wait a minute, prompt retries. That looks interesting. That looks very interesting. So I started to think about a theory. What if prompt retries is less than 5, which is the auto wipe, prompt for PIN, else drop the database? Well, that sounds kind of reasonable, doesn't it? So we've got this theory that prompt retries is basically an iterator. It increases until it hits 5, and then it deletes itself because you've reached the end of your tries. Okay, that sounds perfectly reasonable. So if we edit the XML, change some values, maybe it doesn't know what a minus number is, for example, and then restore it, you know, it sounds reasonable. So we got this proposed attack. Okay, it's a naive attack. It's simple. You back up the data. We've already talked about that. You edit the XML file. You go to this and you say, prompt retries -9999. You repackage it. You put it through the reverse again. You restore it. Okay, so it sounds like an easy process. If that is an easy process, then, well, that's not one of the easiest processes I've ever seen in my life. And trust me, you don't need to remember what that process is. But if you do that, you figure out it's a counter. Simple as that. Great. The good news is we get 10,000 tries. And I'm pretty sure that everyone in the room is good enough to do maths on a 4-digit PIN with 10,000 tries. Pretty sure we're going to get it. The bad news is we get 10,000 tries. I don't want to sit there and type 1111, 1112. You know, it's like, that would take hours, and my fingers would bleed. And I don't, unfortunately, have an intern to do that for me. So let's make it easier. No PIN is better than PIN. So if we go back to the XML file again, there's a couple of different settings in there. Password, reprompt on activate, PIN code for reprompt, which is an encoded version of your PIN, and require PIN. Okay, so you can see where this is going. So it's just 100% profit. So we go back to our early attack. You edit the XML, you just simply remove the PIN. You set a couple of values to 0, and everything is just win. Okay, so I've got a quick video demo, as my demo box doesn't seem to be working. You don't really need to look at the commands because the videos are going to be available online. So we're trying a PIN, failed. Can't get past it. That's a pain in the ass. So we're going to do a quick backup of the information. Okay, I'm using a tool that I'll talk a little bit about later on that automates the process for you. So I'm backing it up. The video is always either too fast or too slow. So it prompts and says, am I allowed to back up the data? You say, yes, I would like to back up the data, which is the reason why you need to actually bypass the PIN in the first place, because otherwise you can't accept it. You go in and you have a little look at the files, and you can see here's the XML file, and this long string here is the encoded PIN. I'm not sure why they bother to encode it, because if there's only 10,000 possibilities, it's pretty easy to brute force that. Let's just delete that, because I don't think we need that. Doesn't need to be anything else, it's just get rid of it. And then we'll go down and prompt for PIN on reactivation. That doesn't need to be a 1, that can be a 0, because we don't need that either. So we're going to save that. We're then going to use another tool, okay, which I'll talk a little bit about later on. Basically, this does the opposite of the unpacking. It takes your unpacked information and the original backup and then recreates the backup for you. And then we're simply going to restore it back into the device. Okay, so that's packing everything back up again. So it's got all of the files that you've packed up, and it creates an output AB file. So exactly the same format as we created during the backup. And we're doing ADB restore. We're specifying the AB file, and then we're accepting it on the device. So back on the device, restore my data, and simply double-click on LastPass, and whereas we previously got a pop-up saying the PIN, there's no PIN anymore. Suddenly we can log in, it logs you into the online website, and we can log in and look at the secure banking details. Simple as that, okay? It's a no-brainer. I mean, so you can then go in and view whatever is stored there, okay? So that's interesting, but I want some bonus points. You know, that's just an easy win. So persistence, we like persistence. Persistence is good. So I found your device, and I've removed your PIN that you thought was secure, and you think your database is all secure and fine, so you go off and you buy a new phone, you install LastPass, you type in your password, you save it, everything's working, you're getting synchronized. So how can we get persistence? So I've got a backup from LastPass on your device A. So say I've temporarily got access to your device, or I found it. Well, I'm just going to restore it to another device, device B, or device B and C and D and E and F, depending on how many you want. So the user's like, wait, I reset my banking password, and I stored it in LastPass, so you can't get access to that, except Profit++. It's even worse than that, because you get everything that they've done resynced to your copy of LastPass. So as long as you have a copy of their backup and you've restored it onto your device, you get every change they make. So you get a constant, persistent access to every piece of their data, okay? So that's enough for LastPass. I mean, LastPass was it's too much of an easy victim, okay? Most of the storage applications I looked at were that bad. They were as bad as LastPass or worse. Some kind of XML file that was very simple to just edit. So good for enterprise. Quite a lot of people use it. I've seen a couple of people logging in here using Good for Enterprise. So if you're in the room, then hi. So Good for Enterprise, for people who don't know what it is, it's an enterprise email solution. You get emails, you get contacts. It even gives you the option of an intranet browser, so you can log in through Good and browse the company's intranet, which is so wonderful. And it's secured with a PIN or a password, which is set with an enterprise policy. And again, you get this auto wipe, usually after 10 false logons, but it's probably configurable on the back end. Okay? In the actual MDM itself, you can say, well, maybe wipe after 2 false logons, and then every time your marketing manager gets drunk, you have to restore it for him. So it also has a couple of advanced security features. It's double encrypted. It's not double XORed or double ROT13'd. It uses an SSL tunnel to tunnel everything to Good. But everything within that tunnel is encrypted using public-private key encryption. So everything that goes over Good, even Good can't read. And then they forward it through their internal infrastructure to your personalized server, and they get access to the email. So they've actually thought about it, because most companies would just say it's SSL, it's fine. So they've actually thought about it. They also have a full MDM solution, as full as you can get on these things. So you can set password policies. You can set restrictions on what you can do. You can set lockouts. You can set a whole multitude of stuff. Okay, but the thing we're really interested in is the password policy here. Okay, it also has root detection, which unfortunately makes it really hard to run in an emulator, because as soon as you run it in the standard emulator, it's always root, so it always says, I'm sorry, I'm not going to run, which makes it a pain to actually test. And there's a thing called advanced detection, which people don't turn on, what you really should. Okay, because people are worried it's going to run your battery down, but that's not the case. So we wanted to look at a scenario. What can we do? So a lost device. Okay, this was a scenario a customer came to us with, and like, what if I've lost my device? This Good container, is it really good? Is Good good, or is Good not good? Can you have a check of it, see what you can do? We'll give you a device, and that's it. That's all you're going to get. So we had a device. We knew what the PIN was, so we could get access to it. But the scenario was, what can you do if you don't know what the PIN is? So can an attacker prevent the secure wipe? Pretty easy. You just turn it off. It doesn't wipe itself if you turn it off. Or you put it in one of those little silver bags that you usually make tinfoil hats out of, and it doesn't wipe itself. And can an attacker access the cache data, which is the big problem? Can you access what's on the device itself? Okay, so problem number one, unlike LastPass, it actually encrypts the preferences. So even if we can get a backup, all we're going to get when we look at the backup is a load of encrypted files that we know nothing about. Okay, so then you can dig through memory, you can dig through looking for any kind of keys and trying to decode how they encrypt things. That seems like a lot of work, and one of the prerequisites of this was to avoid doing lots and lots of really heavy lifting, because this was just like a quick check. And that brings up problem 2. We can't get around this auto wipe. So after 10 logons, it's going to wipe itself. Okay, that really limits us. We can't do anything. It really seems kind of secure. You can't disable the pin. You can't affect any kind of counter for the auto wipe because it's encrypted. And you can't do a brute force because the thing deletes itself after you've done it. And the first thought was, well, if we start playing with this, it's just going to delete itself and then the test is over. There's not a whole lot of places to go once it's deleted itself because it's gone. So we had a look in the Android manifest, and there's this allow Android backup true. Well, there wasn't actually, that's a lie. It just wasn't there at all. And as we know, it defaults to true if it's not there. Okay, so it was true, it just wasn't in the file. So, whoops. Let's just say that it was a little bit of an oversight. And if they'd known about it, then I'm sure they would have fixed it. And they have fixed it. So that's the reason why I'm talking about it today. But the first theory that I had was, okay, so the auto wipe counter, there must be some kind of counter. It must keep track of it somewhere. It's got to be in that data somewhere. It's encrypted, and I can't check it. I can't alter it. I can't play with it. I tried flipping bits and doing bit flipping attacks. No, every time you do that, it just screws up. So you can't just go in there and start fuzzing it and finally find out which bits to flip to affect the counter. So you can't do anything with it on that front. So the second theory was, okay, so we can do ADB restore. We can do a backup. So if we overwrite the entire container, surely that would do the same thing. Okay? So we can't affect the counter, but we can overwrite the counter. So we can simply back up the entire data from the device itself. Try 9 times until it flips and says, if you try one more, I'm going to delete myself. And then restore, and try 9 times again. So suddenly this whole brute force thing becomes perfectly feasible. You know, using ADB restore to back up and restore the data, you know, it's great. You back up the data until good is unlocked, try 9 pins, restore app data, repeat until true. Simple as that. Okay, but that brings back another problem. Time. Okay, time's always the problem with these kind of things, is that if you're going to do a 4-digit pin, it's going to take you 4.5 hours to type in just to hit 50% of the key space. So we're looking at around 50% of the key space. Chances are you're probably going to guess it. Okay, so that's at 18.75 pins per minute, which is about as fast as I could type a pin into a device and then restore, and then type a pin into a device 9 times and then restore. So, and if you start looking at 6 and 8 digits, 8 digits is 5 years. That becomes a huge issue. And the lower alpha, it's months, it's years. And by the time you get into complex passwords, it's years or decades. Okay, so it's just looking more and more unrealistic until you realize that the average person holding a device thinks, I only need a 4-digit pin on this because it auto wipes. So again, it comes back to the security features that you think are making you more secure are leading you into a false sense of security. And what you actually end up with is a device that's not secure in any way. And even though you think it's going to auto wipe, you can bypass those kind of things. So that led us to another thought. We've gone around thinking that the container itself, the Android good container, is connected specifically to the device. But what if it's not connected to the device? What if there is no connection? It doesn't care where it is. What if it's pretty much like LastPass, where you can take it from device A and put it onto device B? So you get this double face palm. So the timing of these attacks, it can take 31 days if it's a reasonably strong password, lower alpha. Well, that's not going to take that long if I put it on 31 phones, is it? I mean, we know that it does some kind of root detection, so you can't use the Android emulator, but it doesn't mean you can't put it on 31 phones and pay 31 people to do it. And I'm sure there are countries out there that will be perfectly happy to do this for you. If you send it to them, they will just get 31 people to just crack it within a day until their fingers bleed. But I want this in a VM. So I hunted around and I looked around and I finally found a thing called Android VM. And I'm sure when Good read this, they will detect Android VM as well. It's now moved to another product called Genymotion. What that provides you is you can just go in and say, I would like a VirtualBox instance of this version of Android, and it will just spin one up for you, okay, on your local machine. As it does some kind of root detection, even though it's not particularly good root detection, you have to go in and unroot your device. So you remove your SU binary, you remove your super user APK file, which is what it uses to detect things. So you don't have root on the device anymore, but you do have as many VMs as you need to just start doing brute force across multiple devices. Okay? So suddenly you just spin up 31 versions of Android VM and you can decode the password in a single day. Okay? So we've got all these clones. We can just brute force passwords to our delight. But unfortunately, I don't want to sit there with Android VMs typing in the passwords. It's no better than typing in on a physical device. Typing it with a mouse is not going to be any quicker. So we want to use some automated attacks. And unfortunately, ADB offers a couple of interesting options, like input text, input key event, input tap, input swipe. So you can specifically say, you script out, please do this, and it will physically do it on the device itself. Okay? So we can automate this. We can put it into a script and we can start getting it to automate the attack, which is great. And we can also look at minimizing the key space. Now, this was talked about by the guys who do John the Ripper a while ago. The password rules, to make it more secure, you're not allowed to have 4, 5, 6, 7. Simple as that. I mean, it's like 1, 2, 3, 4. It's just useless. You can't have that as a password. You can't have 1, 1, 1, 1. You probably can't have 2, 1, 2, 1 because they're far too easy. So you go from 10,000 possible 4-digit pins to maybe 9,000, so it's speeding it up for us. If we know what the password complexity rules are, we can make the attack even quicker because we can skip things that it's never going to be. Plus, the guys from ISEC Partners in the US presented at DEF CON this year, and they released what they claim to be a list of all 4-digit pins in the order that they see them. So you tend to get 1977, 1978, 1979 before 4912 because it's much more common. Your average person picks something they can easily remember, like the birth date of their daughter, the birth date of their partner, the day they met their partner, the day they got divorced, whatever. So you get these common pins and you can really put it into order. So we're kind of reducing the complexity and we're making it a lot quicker. Okay, so the result is a really reduced key space and some kind of pin list that we can use to really do some serious brute forcing. Okay, so I've got a video demo. As I said, the live demo doesn't work, but I'm happy to show anyone after the event. So we have, again, you don't need to see the text so much because it's not so interesting, but we have a simple script here called goodbrute, which is what I was trying to run on this box. And all this is doing is, it's a Python wrapper that wraps around ADB commands. It makes sure that good runs, so it makes sure it works. It does a restore of a backed up good container, and then it loads it up and simply starts to send pins. Simple as that. So it's looking through a pin list, which is what we already talked about. It's got the most common pins at the top, all the way down to the ones that you don't really see very often at the bottom. And it simply goes through and starts trying them against the container. As you can see there, it pops up and says, you've tried 9 times. If you try one more time, I'm going to delete this container and then it's game over. At which point, you close good, you do a ADB restore of your secure backup that doesn't have any tries on it at all, and then you start from scratch again. Simple as that. It's kind of old school. It's the way people used to do attacks on things, or I can just back it up. If it deletes itself or there's a problem with it, I can just restore it. So you wouldn't expect that to work on these kind of devices, but it really does. So when it hits the end, I won't let the demo run to the end, but you can see here it comes up with saying your code is 2526. Okay, this is some random pin that we put in to test it. And it ran 5,000 pins in 5.9 hours. Okay, which is, it's unrealistic. It's against a single host, and that's while my system is also doing a video capture in HD, which significantly reduces the pinning speed of my laptop, unfortunately. So we're usually seeing 5,000 pins, which is half the key space, cracked in something around 3.2 hours on a single virtual machine. So again, if you start bringing that across virtual machines, you can crack a pin in minutes if you want. It's just a case of throwing enough money at it and really setting it up. So great, profit. We can just crack good container pins if you're using the insecure version of good for enterprise, obviously. So we saw this huge list of things. We want to make it easy. Okay, so we've got this common methodology. We back up, we extract, we examine, we edit, we repack, or we restore. Okay, so sometimes you can just do that once, sometimes you're going to have to do that multiple times depending on the vulnerability. Okay, so you remember this process, this short and easy to remember, concise process that I'm sure everyone has in their head. Okay, yeah, try saying that 10 times fast, it's going to make your head hurt. So we need to move to something, we need to automate this. We need to move to an automated way of performing these kind of attacks. Even if you're only doing it once, you don't want to type in all those commands, okay, because we're lazy. We like to put our feet on the desk and let whatever programming language we choose do the job, okay? So I threw a couple of tools together. I released them at B-Sides Las Vegas. One's called AB Unpacker, and again, these are on my GitHub page. As I said on Twitter, if you can't find my GitHub page, you probably shouldn't be using these scripts because Google is very easy to search for things. So there's one called AB Unpacker, which basically does a backup from an Android device. So you connect your Android device, or you specifically give it an AB file. It unpacks it, uncompresses it, gives you a tree structure, and then you can do whatever you want with it. Okay, simple. On the flip side, you get AB Packer, kind of makes sense, which takes the tree structure that you've created, if you edit files, add files, remove files, and it will then recompress it back into an Android backup file, which you can then restore onto the device, bypass a pin, do whatever you want it to do, or add additional content. In a couple of tests, I found that there was a few XML files that contain things like is professional version or has paid for license. Let's just say that. So a couple of interesting functionality features in these XML files because people don't think you're going to be looking at them. So using these scripts is going to make owning things 200% funner. You know, it's going to make it so much quicker. You know, women will love you, people will like you on Facebook, animals will look up to you. This animal specifically, because it's like this small, can't do anything other than look up to you, to be honest. So that's all well and good. I mean, let's review this. Secure containers, not necessarily secure containers, okay? So to your average person, well, it's secure, it's got a pin. But if you know what you're doing, they're not really always that secure. But physical access, yeah, it usually means game over, okay? It's always been the case that as soon as you get physical access to a device, that's it. But these containers should prevent that, and that's not, unfortunately, what they do. So that's great. How are we going to fix this? Okay, we've got this problem where developers, companies, large, huge companies, are implementing these things thinking that they're going to save their corporate data. So we need to be able to fix this, and we need to be able to provide people with pointers. So the first place we need to go is the developers. Okay, they need to know that they can read the documentation, and it will tell them that this is a bad idea. If you go into the documentation for allow backup, it specifically says a couple of phrases. Okay, you probably, unfortunately, can't read this in the back, but the default is true. So okay, so if I'm not setting this, it's going to default to true anyway. Security of your data while using backup. It specifically says the word security. Okay, so you need to read between the lines and say, wait a minute. Maybe if I'm storing clear text XMLs, allowing a backup is probably not such a good plan. You know, it's probably even worse if you're storing license files within a device, within the application itself, because then you can start pirating applications using the same kind of thing, and that's obviously not desirable. But some devs get it. Okay, so while I was doing some research, one of the applications I really, really wanted to be able to hack using this technique was the Google two-factor auth. If I can get that, then that would be perfect. So I specifically looked into the Android manifest, and it specifically says, note, allow backup is set to false below to prevent the key material from being extracted. So some devs get it, okay? The Google devs, who obviously came up with this idea of backups, thought, okay, we don't want that for everything. So some devs get it, and there's information out there, okay? So the preference files themselves, they're not secret. They're on your device. They're outside of the application dev's control. Okay, so encrypt them. Okay, good did good. They encrypted the file. They didn't quite do everything they could have done, but they encrypted the file, and that made things a lot harder. Okay, only store encrypted passwords. Only store encrypted passwords. I mean, Spider Oak, which is one of the things I haven't gone into depth today about Spider Oak, but if you say to Spider Oak you want it to store your username and password, the Android app base64 encrypts your password. Spider Oak is one of the more secure tools. They're like, oh, we encrypt everything, and everything is open source, and so they're aware of the problem. They were revised 4, 5, 6 months ago now. But it's like, encrypt your passwords, guys. And base64 is not encryption. And don't trust the config file. Okay, so if I can go in and change things in the config file outside of the application itself, that's wrong. There should be some kind of HMAC, some kind of encryption, some kind of signing that says, oh, you changed it? No, I don't trust that anymore because you've screwed with it now. So there needs to be some kind of validation there. And when it comes to Android backups, very simple. Disable it if you don't need it. If your app does something even remotely secure, turn it off. Specifically say Android backup allow false. If you need it, turn it on. But I really think the default for allow backup should really have been false for security reasons. Okay, but Google don't see it the same way. We've discussed it. But they really want it to be true to allow people to back up their own stuff. But if you're doing anything even remotely secure, if you're doing a banking application, you're doing anything that stores any kind of secret data, always turn off the backup, especially if it's a cloud service. There's no need. It's in the cloud anyway. Why do you want a backup of it? All it is an application with a username that connects to the internet. Why would you need to save that? Everything's on the cloud. Okay, so just turn it off. So adding a little bit of extra security as well. USB debugging, which is one of the requirements for this. Applications should just say, I'm sorry, you have USB debugging turned on, I am not running. Simple as that. Okay, so good. One of the things we talked about at the beginning was good technology have advanced security features. Now this is one of the advanced security features that no one ever turns on, is if you turn on advanced security features, it will actually say, I'm sorry, you have USB debugging turned on and I'm not running. Simple as that. So that would really cause problems for our automation of the attack, because we simply wouldn't be able to do restore. Every time we did a restore, we'd have to enable USB debugging manually, do the restore, turn it off. You'd have to find another way of getting around it. Okay, so it's another hurdle, but it's one of those hurdles that's really going to cause problems for people doing automated attacks. And as we hinted right at the beginning, root makes these attacks easier. Root avoids us requiring allow backup, because as a root user, I can just go in and edit your XML on the device itself. I don't even need to back it up, expand it, edit the XML, restore it. I can just go in specifically to the location, do a backup of the files locally on the device, do the brute force, and then copy it locally on the device. It's quicker, it's easier. I don't need allow backup. I don't need USB debugging turned on, but I do need some kind of root access. So root access makes things even worse. So when you're trying to plan for root access on a device, then encrypting the preference files is the only way you can avoid people from screwing around with things. Okay, and the root detection on most applications is just feeble. If you start looking at applications that say we provide root detection, all they do is check, if I run SU, do I get root? Okay, stands to reason. So what's the further checks? The further check would be, is there an application called super user? Well, if that application tomorrow is recompiled by someone to be I'm not super user, then it won't detect it. Okay, so I had root access to the devices that we were testing by renaming SU to I'm not SU. Okay, this is the technology we're dealing with is the root detections are just not particularly good. And when it comes to end users, so the end users, the enterprises that are using these technologies, encrypt your devices. It's a big hint, and everyone says encrypt your device, and it's not perfect on Android. But if you encrypt your device, it encrypts your backups. So even if I have your device, if I want to back anything up using ADB backup, I need to type in your encryption key so that I can do the backup. And then the resulting backup is encrypted with your encryption key. So if I know your encryption key, then it's still game over, but that's kind of a leap in a certain direction. So always encrypt your devices if you can. And again, disable USB debugging. It stops. Even if I don't have the PIN, you can pull and push data off, and Dropbox stores things in an area where you can just pull it off without even knowing what the PIN is. So always turn off USB debugging if you don't have to. And don't lose your phone. The best protection is to not lose your phone, okay? My girlfriend loses her phone all the time. I always keep my phone with me. So avoid losing your phone if you can. So that's Android secure containers. Any questions?
nice talk, by the way. Do you think that we can reach any kind of reasonable security on device without having keys stored in the hardware itself?
This is the problem, is that the stuff we're talking about today is if you want to secure things, then the next step is to encrypt things. But as we mentioned with good, is that even if you're encrypting, yep, the device still has to know what the encryption code is to be able to decrypt it to run. So all you're doing is upping the level of security from beginner noob, aka me, yep, to I know how to use IDA, which is level 3. So the problem is that the device always needs to know what that data is, and as the device always needs to know what that data is, the only way to protect it is to prevent people from even being able to get access to the device, either physical access or logical access. So the PIN protections alone are not good enough. You need something more robust to make them secure. And Android, unfortunately, doesn't seem to offer those kind of solutions.
Yeah, so we can have a reasonable security without having keys necessarily stored in the hardware for decryption of containers, you think?
Without using something like two-factor auth?
Yep.
Yeah. I mean, but the problem is that your two-factor auth is on your phone. Yep. So, and then even when it's not on your phone, if there's a key fob, people hang it from their phone. So if you lose your phone, chances are you've lost your two-factor auth as well. Or yep, you use SMS for two-factor auth. The problem is that combining those two devices is fundamentally stupid.
Oh, that's reasonable.
Simple as that. Yeah.
Thanks.
No problem.
Did you try use any of the applications made for making backups to try bypass the allow backup false thing in the manifest?
I didn't, mostly because things like titanium backup all require root in order to do the backup. But they would bypass the allow backup, because the way they do backups, from my understanding, is at a file system level. So they don't care what the application says. The allow backup is purely there for ADB to say, I would like to back up, but I'm not allowed to. If you're using something like titanium or you have root access to the device, it's game over. Even if you have allow backup turned off, you can just copy the files, either through a backup program or just by copying them at the shell. So, yeah. So. Any other
more questions?
Well, if anyone wants to see the demo that failed hideously, then I will be around for the rest of the day. If you have any questions, then just let me know. And I have the slides, the demo videos, and the scripts are either up on my GitHub, or I have USB keys if you want them. So feel free.